Hello there, welcome to my channel on chemistry lessons. This is an AQA A-level chemistry and we're going to look at the structure of DNA. So this is what the specification looks like then. We will be referring to this throughout the video to make sure that we hit all of these points. First up though, if you don't subscribe, please do. Your support is very much appreciated. Thank you. Right, back to the specification then. Now, you are given this information in the data book, and that's what the first bullet point tells you. It tells you that the structure of a phosphate ion, there we go, there's our phosphate ion. The structure of a 2-deoxyribose, there it is right there, and the structure of the 4 bases adenine, guanine, cytosine and thymine. I've got no idea why we've got glucose because I don't think we need that. First up then, let's look at what a nucleotide is, because that's the next bullet point. Look, a nucleotide, we are told, is made up of a phosphate ion bonded to a 2-deoxyribose, which in turn is bonded to one of those 4 base pairs. Now, because you'll always be given this data book, you always have this in the exam, what I'm going to do is I'm going to kind of ignore the glucose because we don't need that for this section. Now, the bonds on the 2-deoxyribose are always where the HOs are, okay? So all these OH groups, there's 3 of them, look. So these are where the bonds are going to take place. Now, the phosphate bonds at these 2 HOs because actually phosphate bonds twice to a 2-deoxyribose, but in one nucleotide, you can just put it on either of these 2 positions here, either here or here. Textbooks tend to stick the first nucleotide up the top. Sorry, not the first nucleotide, the first phosphate up the top. So this OH group will go and there'll be a phosphate in its place. And I'll show you what I mean by that. So let me try and draw my 2-deoxyribose down here. CH2, then it goes down, goes across there to an O. Beautiful artwork here. And this is like a pentagon. There you go. And then it goes down here. H here. As long as I'm correct, it doesn't matter if it's a bit of a mess, because in an exam you could be asked to draw a nucleotide. Right, so I'm purposely not drawing the OH up the top here because this is where my base is going to be bonded. I said that the 3 HOs are removed in DNA, so you don't have any of these 3 HO groups in DNA. Okay, I'm going to put the HO group down the bottom though because I'm only drawing one nucleotide, and I've decided that I'm going to put my phosphate up the top. So the OH group has gone and instead it's bonded through this O in the phosphate. Again, it's all about the HOs. So it's these 2 HO groups on this phosphate is where it will join to 2-deoxyribose. So what will this phosphate look like? Well, both the O and the H don't leave, it's just the H that's not going to be there. So this O and P, double bond O, single bond O minus up to OH. There we go. So I've now bonded my phosphate to my 2-deoxyribose. I could, as I pointed out, I could have bonded my phosphate here as well, because the truth is it will be bonded to both in a strand of DNA, and we'll see that later. Delete. Right, okay, so now what I need to do, there's my phosphate bonded my 2-deoxyribose. Now I need to bond my base to my 2-deoxyribose. And it bonds through, as I said earlier, this other HO up the top right here. So this is where your base bonds. Now the base bonds through a nitrogen, and it's always, as we look at the periodic table, it's always the bottom right nitrogen. So if it was adenine, it would be this nitrogen. If it's guanine, it would be this nitrogen. If it's cytosine, it's this nitrogen. And if it's thymine, it's this nitrogen. So it's always the bottom, the very bottom row to the far right. In the case of cytosine and thymine, there's only one nitrogen at the very bottom. guanine and adenine have several, so it's the bottom right. Okay. Always refer to your data book here, because if they want to make an exam question slightly more awkward, then they would draw this slightly differently. Because what I'm going to have to do now, I'm going to just pick eeny, meeny, miny, mo. I'll tell you what, if my 1000th subscriber just shouts out a random number between 1 and 4, please.
Number 3.
Excellent, thank you. So we'll go with number 3. So this, I'm going to attach cytosine to my 2-deoxyribose. And that will bond, as I've said, here onto this carbon. Now the OH group goes from the 2-deoxyribose, and the hydrogen on this nitrogen has gone. So this now is just nitrogen. So this nitrogen here is going to be this nitrogen on cytosine here. So what do I have to do? I have to finish this into, it was a 6-membered ring, it's like that. Single bond, double bond, nitrogen, then single bond, oxygen, and then I've got an NH2, no, it's not there. I almost made a mistake. It will go, NH2 will go there. Let me check that. 1, 2, 3, 1, 2, 3. Perfecto. So what I've just done there is I've shown you the structure of a nucleotide. A nucleotide is one phosphate bonded to a 2-deoxyribose. And remember, there's 2 possible positions, either this carbon here or this carbon here. So one of these OH groups, or both of them in fact, will leave. But for one nucleotide, I decided I was going to stick my phosphate on the top left instead of the bottom left. And then I had to choose one of the base pairs, or one of the bases, sorry, and my 1000 subscriber beautifully called out number 3, and I decided to stick cytosine onto the 2-deoxyribose, and the base goes up the top right on that OH group. So what I've just drawn there is a nucleotide. Okay then, so what we need to do now is to see how these nucleotides make up a single strand of DNA. So a single strand of DNA is literally many, many nucleotides bonded together. Okay, so we've got, let's try and have a look at this diagram. So thanks to this diagram here from Biology Stack, big up the Biology Stack. So what we're looking at here is a phosphate. So this section here would be classed as one nucleotide. We've got our phosphate, 2-deoxyribose, and the base. So we've got 1, 2, 3, 4. We've actually got 4 different nucleotides shown here. Now a single strand of DNA can have thousands of these. So I'm led to believe. I've never seen them myself. But what we've got here, if we look at the backbone, we've got a backbone of phosphate, 2-deoxyribose, phosphate, 2-deoxyribose, phosphate, 2-deoxyribose, phosphate, 2-deoxyribose, and this is the repeating pattern. So you've always got a phosphate, 2-deoxyribose, phosphate, so on and so on and so on. And then each 2-deoxyribose has its base bonded to this carbon, as we've seen on the previous slide. So you've got many, many, many of these joined together to make a single strand of DNA. Now, what do we mean by complementary strands? Because I've just talked about a single strand. Now, DNA is actually 2 strands that complement each other. So let's have a look at what we mean by this. So these 4 bases, the adenine, guanine, cysteine and thymine, they pair up, and they always pair up in the same way. So adenine always pairs with thymine, and guanine always pairs with cytosine. The easiest way to do this, and I worked this out last year and I was really proud of myself when I did this, is what it looks like in your data sheet. Okay, Now, what I imagined, or what I suddenly realised, I'm going to pretend I had like a Kekulé moment. We'll call it Bryson's theorem. And I was kind of sleeping in front of the telly. Yeah, that's it. I was sleeping in front of the telly, and pictures started running through my head, and I imagined myself folding this data sheet in half. And when you fold it in half, the adenine pairs with the thymine, and the guanine pairs with the cytosine. Watch this. If I folded it in half, thymine would be a mirror image. Whoa, and it would sit on top of the adenine like this. It would sit directly on top. And the cytosine, again, if I flipped it over and folded it, it would look just like this. And even better, why I'm getting so excited about this, is we have a bond here, a bond forms here, a bond forms here. Okay? So we end up with a bond here and a bond here. So you end up with two bonds, or two hydrogen bonds between thymine and adenine, and you end up with three hydrogen bonds between guanine and cytosine. Let's see that in a little bit more detail. Remember, that was Bryson's theorem. I fell asleep in front of the telly watching that. So in textbooks, if you're going to write a textbook, that's what it's called, right? I fell asleep watching the telly. It was YouTube. Can't remember what it was. Yes, that was it. Thanks. So here's our four bases. We're now going to look at how they form their hydrogen bonds, or where the hydrogen bonds form between these four. Okay, so we know that adenine will always pair with thymine, and we know that cytosine will always pair with guanine. And Bryson's theorem, fold your data book in half, abracadabra. Adenine pairs with thymine to form two hydrogen bonds. Let's look at where they are and what they look like. So there's a lone pair on this oxygen, so there's always a lone pair on your carbonyls, okay? And that will interact with your delta positive hydrogen on this NH2. So what I should really do is draw a hydrogen coming off here. That pen colour's not very clear, is it? I use a red. So we have an interaction between this delta plus and this lone pair. There's hydrogen bond forms there. And also there's a lone pair on this nitrogen here. And that interacts with this delta positive hydrogen. So there's our two hydrogen bonds. Okay, 1, 2. Now when it comes to the cytosine and guanine, there's three hydrogen bonds. The same scenario, the only difference is there's another one down the bottom here because we've got another carbonyl here. So delta plus on the hydrogen here, carbonyl, lone pair on this nitrogen here, this delta plus hydrogen, lone pair on this oxygen, delta plus on this hydrogen. So remember, the carbonyl O's have a lone pair, and the nitrogens on the ring have a lone pair, and that's where you see the interactions. Okay, so two hydrogen bonds between adenine and thymine, three hydrogen bonds between guanine and cytosine. So just to zoom back out a bit, and again, thanks very much for this picture here. Again, I ripped this off the internet, so full credit. We've got complementary strands. So we're seeing two strands. On the left-hand side here, we've got two strands of DNA complementing each other. So DNA is in fact two complementary strands in this alpha helix. And they complement each other to pair so that their bases pair up. Okay, you'll see that A always pairs with T and G always pairs with C. A being adenine, T being thymine, G being guanine, and the C being cytosine. Okay, and we can count the number of hydrogen bonds. 1, 2, 3, 4, 5, 6, 7, 8. So in this section, there's 10 hydrogen bonds between those two complementary strands of DNA. So the backbone, just final key point, your backbone was your phosphate, 2-deoxyribose, phosphate, 2-deoxyribose, phosphate, 2-deoxyribose, phosphate, 2-deoxyribose. I should become a rapper. So that's your backbone. It's the same with the other strand of DNA. That's your backbone. And then you've got your base attached to your 2-deoxyribose, and those bases will pair up to complement each other. And that brings this video to a close, people. Hope you enjoyed it. I did.